Okay, hello everybody. Welcome to the numerical recipes for machine learning. Okay, so the topic of this class is to review the algorithmical aspects of the machine learning methods that we use now in our daily life, or that at least impact our daily life. So the most important thing in my view is the class organization. Because the class is organized as a challenge-based learning. So you will always be working in groups, and I will deliver a challenge every 2 weeks, and you'll be asked to present your solution to the challenge every 2 weeks. And so the class organization is a little bit different in the sense that there is very little frontal teaching, and it's mostly based on students presenting their own work. Okay. So the idea is that it's a student-centric approach. So the topic, the goal of the class is collaboration. So first of all, for students to collaborate with each other. Self-learning, meaning that I will only present partially the material of the class. Then it's going to be your goal to learn by yourself. Digital fluency, I will expect you to write code using generative AI tools. Communication, so a large part of the class will be students presenting their solution. So you will need to be able to effectively present what you did. And of course, creativity is always there, right? So you'll be given an assignment which usually requires a certain level of creativity to be addressed. And we always favor creative solution to, let's say, numerically intensive solutions, okay? So we always prefer to see a creative approach to an exhaustive approach. So let's see how the class will run. So I keep a document here. The link is this one here, which is I try to keep updated as much as possible, and this describes how the class is usually run. And so yeah. So the document is exhaustive as possible, meaning that there are aspects of the class that are sort of require certain logistics. So all the logistics are discussed in this document. For example, how points are evaluated, how the teams are evaluated, what is the grading policy, this type of things. All the logistics are in this document. So if there is something which is not clear, please go to this document. If it's also not clear on the document, then leave a comment to the document. So this is a comment link, which means that that you can leave a comment, so I can address it later. And then in this class, we just want to present the main discussion points. Okay. So the main elements are as follows. Every 2 weeks, you get a challenge that you will solve in a group of 3, 4, 5, 6 people, depending on the total number of people in the class. Once the challenge is completed, you will present it to the class and you will submit your material online. And then the other members of the class will review your work. And then the sort of the last challenge of the semester will be a final project. And it will take 4 weeks, 4 to 5 weeks. And this will be a large portion of your grade. So the idea is that at the end of the class, you will be able to recruit the best team members that you can, and then you will work on this. These are the phases of the class. So at the beginning, we will randomize the members of the class so that everybody gets to work with each other. Of course, this introduces a lot of uncertainty because not all the you will not know the people that you work with in principle, but you will have the chance to meet them during this first phase. And then in phase 2, we will select a couple of group leaders, and the group leaders will select the group members that they wish to work for. And then on phase 3, you will simply focus, let's say that the interaction among the team members should be completely fine-tuned and resolved, so you can just work toward your final project. So again, phase 1, the group members are randomized. So everybody gets a chance to work with each other. And then you will receive a grading in terms of your performance in the group. In phase 2, you will select the group members in your team. So in this case, there is no evaluation of the students. So the evaluation is only per team evaluation. Okay, so in phase one, you will receive an evaluation which is a personal evaluation, but in phase two, your grade will be shared with all the other members in the team, and in phase three, again, so the grade is the same grade for all the people in the team, and this is the largest portion of the grade will come for the final project. So as a member of the class, you will also provide evaluation. So in the first phase, you will have an intra-team evaluation, which you evaluate the performance of the other members in the team, and a cross-team evaluation. So you will receive the files submitted by another team, and you evaluate this other team. And then in phase two, you'll only have the cross-team evaluation. So since everybody will receive the same grade in the class, in the team, you will just evaluate the other teams. And when you are asked to evaluate the team members in the phase one, you will be asked to score the people, not only in terms of their performance, let's say the absolute performance, but also the relative performance in terms of the role that they take in the team. And in particular, we expect that you'll be able to rank, to classify the team members in terms of leader, thinker, and doer. Okay, so the leaders are the people that take the leadership, that assign work, they check their work gets done, that provide the idea, right? The thinkers are the people that step back from, let's say, from interaction with the other members, and they come up with innovative solutions, and they use their time for deep thinking instead of coordination of people. And then the doer are the people that sit down and try to write the code and implement things quickly and turn, let's say, the project into reality. So so at first, say the first approximation, this is how we expect team members should be ranked, should be classified. And then if you see, you'll at the end of the challenge, we will have 12 challenges, one of which is the final project. And what you will submit is a written report, it's a video report, and the code base. Of course, we expect everything here to be aided by generative AI. So for all these aspects, we expect you guys to be able to use generative AI to produce this material, and also to be somewhat effective in shaping the material to be as informative and as complete as you can. So when we try to rank the submissions, we have had this experience that if we just let people give grades, then the students will just give 10 to everybody, and so that the grade is not useful because everybody will get 10. After giving this opportunity to the students, we let them, we chose to let them rank the different teams. But also when people started ranking the other teams, people complained because they said that they were forced to choose a ranking between, let's say, 3 teams, but the first team and the second team were very close, but the third team was terrible. So they complained that that the ranking did not give enough differentiation in the grades. And so what we came up with is this over-ranking system, which is you give a rank between 1 and 10 to all the submissions that you're ranking, right? And then this ranking. So let's say that you are ranking 3 submissions. Let's say that the first and the second are very close, but the third one is very far away. You can rank the first and the second, let's say number 1 and number 3, and then the third submission is number 10. Then we will convert the ranking into a score between 1 and 100 with this formula here, right? So there is a total rank for the team members or the submission divided by the max rank, so that everything is scaled so that the difference in ranking is what determines the final score. Okay, so it's a little bit laborious, but it's just, I mean, from your perspective, it doesn't change much, right? So you have 10 positions, you have to choose who to place in which position between 1 and 10, and you have to keep in mind that the difference in ranking will convert to a difference in score, and that's it. Okay. So again, this is to trade off between ranking and scoring. Okay, so we call it overranking. The final grades is straight up average, weighted average of the scores in different phases. Notice that phase one has a very low contribution to the final grade because phase one is very challenging because groups are chosen randomly. So there is more uncertainty in your grade in phase one than in phase 2 and 3, where you're able to choose your group mates. And then let's see. Let's see what are some of the facts that we received. So the course will run in Python. So you will be asked to produce this algorithm that we are discussing about in Python. But of course, we will not describe. We will not spend any time in teaching in Python. Of course, LLMs have vastly automated the idea of writing code. So it's not really compelling for you guys to sit down and study the specifications of different functions. So when I was your age, we would study C++, and one will have to memorize not only the syntax of the C++, but also a certain amount of functions, what type of parameters a function will take in input, what will produce in output. But that's because the speed at which the code will evolve was very, very slow. So if you remember how to use a certain package in C++ for mathematics, then this will remain the same for the next 25 years. But of course, now this is not very relevant because you can just ask an LLM to give you the line of code which is relevant to you. So not very interesting. Then if you see, we're going to use Slack to communicate. So Slack, yeah, you should have. Did you join Slack already? Let me ask. Did you guys join Slack already? So usually, yeah, try to join. This is the link. Of course, if you have any question, let me know. So. Member invite link. So this is the invite link. So you guys, I guess you're familiar with Discord. Do you guys use Discord? So on a Slack, it's like Discord for people that have jobs. Discord is it's a tool that is, let's say, targeted to a different demographic, right? So usually this is the team management tool that I use. I use it. I know it's not as convenient as Discord, not as well developed, but we know that Discord had some security breaches. Also, Slack has had some issues. Anyway, so it's just a team that I prefer. Is a team management tool that I use. Of course, E3 is a joke. It's not really you cannot really do team management, right? So you're invited to use the tool also to communicate inside the group. If you don't, it's your choice. You can use a lot of students use Line because we're in Taiwan. A lot of people use, I think nobody uses Facebook. I hope nobody's using Instagram. But anyway, you got my point. E3 is generally an insufficient platform for anything, especially for team management. So bear with me. Install Slack, and my response time on Slack is very quick usually. So try to trust us at least. So when people take the class, usually there is hello, welcome. Sorry. So the class started late because I got confused. Apologies. Try to follow the presentation, then it's shared in chat, so you can see it in chat. So I was saying, yeah. So usually the challenges they come from the challenges I will explain. Yeah, sorry. Oh, everybody's here. I think we have 9 people. Yeah, because I tried to invite you by email, guys, but didn't work. So let me start over. So we'll discuss. I'll redo the presentation, okay, very quickly for you guys. So please come and join Slack here.
So we do have the money. And then also like
So it joins.
that's dedicated.
There's one guess. What is one guess? There's somebody trying. Just a second.
Yeah, but also like the numbers is it different? The most
Okay, very good. Again, apologies, guys. There is a certain Jerry guy that is not there yet. Okay.
Oh, it is this one.
Okay, so I'll redo the presentation, no problem. But anyway, so follow from here. So the challenges usually will be somewhat, they will seem somewhat unrelated to what I do teaching class. And this is somewhat by design, meaning that in class I will just present the basic behind the challenge, and then we'll go forward. Okay, so I'll redo the presentation for the people that just joined. So if you have a difficulty following the class in English, just put the subtitle on Google Meet and you'll be happy, I hope. I have a certain accent in English, but what can I do? Then some people complain that working in groups is laborious and you have to spend a lot of time synchronizing people. And I have to say that this is the reality of life. Okay, so when you go to work, you will realize that you spend most of your time trying to get your colleagues to work on the same problem, and there is a lot of time which is wasted in communication because it's very hard to align people to work together. So this is an experience that you're going to have for sure. And yeah, so some people complain. So let me just redo it quickly, the presentations, as we have a few new people. Again, welcome to the numerical recipes for machine learning class. Apologies that the class started late because it's the first week and I got confused because the class has 2 slots, has a 2-hour slot plus a 1-hour slot. I thought that the 1-hour slot was on Tuesday and the 2-hour slot will be on Thursday, but it's the opposite. We will always use this slot only, okay? So even if the class is 3 hours, we will use it for 2 hours, okay? So it would be very rare for me to have the need to run the class for 3 hours a week, basically never, apart from maybe if there is some holidays that intersect with the class and so on. And once I start explaining how the class is run, you'll understand why. Very good. Listen to these guys. So let's run through how the class is organized. A little bit of a pack, a Q&A, and then I will explain the pedagogy, a little bit of the class. So again, so if you were here from the beginning, apologies. I'll try to make it more compelling this other time. So the idea is that the class will be running challenge-based learning. So it's focused on collaboration, self-learning, digital fluency, communication, creativity. In that you will work in teams for throughout the class. You will be expected to look up the material in the class by yourself using whatever tool it's convenient for you. You will be encouraged to use generative AI tools, modern LLMs for the whole topic in the class. And you'll be expected to, let's say, be able to shape the output of these tools to be compelling for the class. There will be a lot of in-class presentation. Basically, the whole time in class will be in-class presentation. And then we will always reward creativity in the solution. What is the logistic of the class? So I made an effort to describe the pedagogy of the class in this document here. So I think I shared it online. I shared it. Yeah, you should see it. Let me pin it. Let me also share this presentation. Yeah. You should have access to this presentation as well. So the idea is that every 2 weeks you will have a challenge, and the challenge is something that you have to address into groups, 3, 4, 5 people, depending on how numerous is the class. And then after the challenge is completed, my scoring of the challenge will have a certain percentage, but the largest percentage will be represented by the scoring of the other teams to what you did. And then there will be a last final challenge, which will account for the 40% of the grade, so majority of the grade. The class has 3 phases, so phase 1, phase 2, and phase 3. Phase 1, we will just have a random formation of the groups. Phase 2, you will ISA will be after the midterm week, and you will be able to select the group members. And then we have phase 3, which is the final challenge. It will the one, it will be, say, the pinnacle of your performance in the class. So in phase 1, as I said, the group members will be randomized. So this is for allowing you guys to get to know each other in the class. In phase 2, there will be some leaders, and the leaders will select the members in the team. So you will agree with the team. You will know who is in the team. I mean, you will have chosen who is in the team, and then there will be a final project in which you can choose the final performance of it. So phase 1. Phase 1.
If you log into the account, you no longer.
So in phase 1, you will have an intra-team evaluation. In team 2, you will have a cross-team evaluation. In phase 2, you only have the cross-team evaluation, meaning that in the first phase, you will be asked to evaluate the other team members in the class, in the team, and then you evaluate the submission of the other people. But in phase 2, you will just have be asked to evaluate the performance of the other teams. That's because in phase 2, everybody will get the same grade. So when we evaluate the students in the first phase, our goal is, of course, not to, let's say, shame or I don't know, say something about people, but mostly we want to know what type of a role they usually take in the team, and that we expect that there is somebody that is focused on leadership, so organizing the work of multiple people. Then there will be people that instead take a setback role, and they focus on coming up with ideas and working on the foundational knowledge of the challenge. And then there are doers, which are the people that focus on coding and implementing things. And so this is where we will ask you to rate your team members. And then there will be a cross-team evaluation, would be based on a certain material. And this material will be a written report, a video report, and a code base. Of course, we expect you guys to be able to use generative AI tools for all of this. And so it shouldn't be a big burden on you preparing this report. This is how we will rank the students. Basically, what matters is this. So you will be asked to rank either the team members or the other submission in terms of a number between 0 and 10. And you will not be able to repeat the ranks. And the final score, let's say, will take into account what is the difference in ranking of the submission, so that you will be able to have a certain ability to provide different ranking, different scores, different final scores to different submissions.
Water stress.
Final grade 25, 35.
And the locations of the video.
And the idea is that the phase 1 is the hardest phase.
So when you download it, it's just a
focused
CSV
on,
file containing the.
like they say, the information is random, so there's not too much to
According to
ask
the
there.
time and the current values.
And that's it.
But
I
it's
think
also-
most of you joined during the SOC,
Figure it out. on your
so
own.
we went through this already.
You need to reprocess it.
And yeah, so there are some other slides here that are more on why we expect the class to be run, why we expect the working group will be really the topic, the relevant way of teaching a class. But I'll link these slides for you. Let me ask some questions in chat. That's it. Have you already taken one of the classes? So I know that Philip already did.
Account creation.
So we have 2 people. Let's see about the others. Let's hear one. Yes or no.
Well, the difference is we focus on the land in Copernicus, so we only have access to that right now. And if the challenges require LSTs different, you don't have.
And say in chat about guys, please. I mean, at least you join the class. Okay, so 2 people haven't taken. So so far we are 2 and 2, right? Okay. Okay, good. So yeah, so I think yeah, I think this is pretty much what I want to cover for today. So let's be honest, guys, the numbers are a bit low for the class. So I want to give you maybe an example of the type of discussion that we will have, and I will send it to you over E3. If you go, try to get some people to join the class, because we only have, just let me check, 1, 2, 3, 4, 5, 6, 7. Yeah, we have like 7 people in the class, so we would be able to run at most 3 groups, let's say, which is not very important, which is not very nice. And the good thing is that you guys can really get to know each other, so it will be nice. So yeah, so try to go and see if you can find some friends of yours to join the class. The class organization should be pretty light. The atmosphere of the class usually it's fairly relaxed. We record everything. We always put everything online. All the material has to be there. Yeah, I mean, that will be the worst case, right? So if there are 7 people, then we will have 2 people per group. It will be a little bit low. So at least 3. Let's say at least 3. At least 3. Because otherwise it will be too little people. And of course, the smaller the group, the easier the challenges. Meaning that I would like to give you some substantive challenges, right? So that you really need to work in group together. So go out and find some friends. I'll try to send you a set of slides to show you what we usually do. So I'll send it here. Let's see. Let me do it here. Announcements. I'll send a new announcement later, and I'll give you some slides. I'll just show you this set of slides here, just to make you think a little bit what are the type of topic that we will do in the class, right? So let's do this. There is this set of slides that I like that describes root finding algorithm, right? So let me just find something nice. I wanted to describe to you this. So this is a topic which I usually use to explain to people the importance of numerical algorithms, because you know that the way in which computers store information, it's in terms of different data formats, right? So there are the easiest data format is unsigned integer. So binary representation, you have a bit per digit. Of course, the range is very limited, not very useful. So what computers usually use is this floating point arithmetic, where you have a certain number for the mantis and for the exponent, so that every number is represented as c to the k to the power of e to the k. And this is standard, which is very well understood in computer architectures, and is able to describe very large number and very small number. So it's much more useful than a binary representation of a number. And it describes, so let's say that this set of slides describes what is the full range of data that you can have, but also it shows that there is a difference between the successive numbers in the representation of numbers in the computer, which is really what determines the precision of your operations. Meaning that for small numbers, there is a small distance between 2 successive numbers that can be represented in the computer. For large numbers, there is a large difference. So the type of operation that destroy the precision of an algorithm is when you move from a small representation to a larger representation, and then back to a small representation. Classical example is logarithm of the exponent of something. Okay, so if you take the exponent of a certain number, then you go to a very large number. And then if you take the logarithm, then you go back to a very small number. And this type of operation, they destroy the precision of the algorithm. And it will not be hard for you to understand that this is destroy the precision of the algorithm. Okay, so this is just to give you an idea what the topic of the course will be. Okay, so the rest it's in the syllabus. So if you have any questions, let me know. And as I said, so the most important thing is the class organization. So working in groups, presenting the challenges and so on. So this is what matters. So yeah, so the message for today is go out, try to find some more people to join. And then next week we talk again. I will not be late. The link will be in the calendar. So the link will always be this one here. So look, this will be the persistent link that you have to click to join the class. And we always record class and then we post on YouTube. If you want to check the past classes, just go to my YouTube channel. There's a very small number of subscribers, but they're all excellent subscribers. And there's a playlist here.
We don't still have a clear goal.
Yeah. So this is the playlist from last semester that now found it, our TA in chat. Yeah, and I think that's it for today. Any question? Any questions? Of course, I'm very generous with my grades. That's it. But of course, I think the class is nice regardless of the relationship between the amount of work and the grade that you get. Yeah, let me know if you have any questions. Okay, very good. So again, I'll meet you next week. Go out and try to find some people. And next week, we'll discuss more about the precision, the algorithmic precision, and then we will cover some fundamental, some basic material, and then we'll give you the first challenge at the end of next week. Okay. No class on Friday. Yeah, it's very inefficient. It's just one block of 1 hour. So by the time that everything goes, everything starts, class is over. So it's not very efficient. Any other question? I'll take note what to send over. No class on Friday. Send the slides. Find class members. And that's it. Okay, guys. I'll see you guys next time. Just as a note, we will always record. So this class, maybe we don't post it, or maybe we post it. Let's see if people want to see. And then for the following, you will always find on Slack the material for the class, and then the video recordings will be on it. Okay. If there is another question, say hi to you guys. Okay. Ciao, guys. Bye.